In the last video, we talked about the purpose of drug metabolism. So at this point, you should be able to answer this very straightforward question about the purpose of drug metabolism. So at the end of the video, we'll go over the answer to this. So if you want to pause the video, select your answer, and then we'll go over it at the end of the video. In this video, I want to dive into phase 1 and phase 2 reactions. So starting with phase 1, you should know that phase 1 has three main subcategories. So within phase 1, we have oxidation reactions. We also have reduction reactions and hydrolysis. But the most important of these three that we're going to talk about extensively is going to be oxidation. So we're really going to focus on this first subdivision of phase 1 metabolism reactions. But you should know that there's also reduction and hydrolysis. So diving into phase 1, specifically oxidation, we can then divide that into the different enzymes. So you can have CYP450 enzymes, and that's going to be your, again, most extensive list, CYP450. And that oxidation the other enzyme for oxidation can be alcohol or aldehyde dehydrogenation. So there's other enzymes that will do alcohol and aldehyde dehydrogenation. Alcohol and aldehyde dehydrogenation. So those metabolism reactions are not done through CYP450 enzymes, they're done through other enzymes. Okay. And then there's another one that you'll learn in a later PPT course, which is oxidative deamination. So overall, we see these three subcategories: oxidation, reduction, hydrolysis. Within oxidation, we're going to have several different phase 1 reactions that are done by CYP450 enzymes. And then also we're going to see alcohol and aldehyde dehydrogenation, which is done with different enzymes, non-CYP450 enzymes. And then in another course, I believe you will go over oxidative deamination. So not only are we focusing on oxidation now, we're focusing on CYP450, right? And then the first organ that should come to mind when you think of CYP450 metabolism is, of course, the liver, as I'm sure you know from lecture. All right, so now that we've gone through those subdivisions, I just want to list the different metabolism reactions. So you have aliphatic hydroxylation. And you should be able to write these lists by memory so you know what to look for whenever you look at a metabolism reaction. There's also aromatic hydroxylation. That one's my favorite because it's pretty easy to identify. Whenever you see a benzene ring, you can just add on a hydroxyl group and assume that that's a potential phase 1 metabolism reaction that could occur. We also have N-dealkylation, so N for nitrogen. This one's usually pretty easy to identify as well. And then we also have N-oxidation. A few more. We have OS dealkylate, OS, so oxygen sulfur dealkylation. So those don't occur together. It's either oxygen dealkylation or sulfur dealkylation. And then we have sulfur oxidation. So what you'll see is N-dealkylation is more common than N-oxidation, and then S-oxidation is more common than S-dealkylation. So I'll say that one more time. You'll see N-dealkylation a lot more commonly in your metabolism routes compared to N-oxidation, so nitrogen dealkylation is more common. And then for sulfur, you tend to see sulfur oxidation instead of sulfur dealkylation. So that's why I think aliphatic hydroxylation, aromatic hydroxylation, N-dealkylation, and then I skip straight to S-oxidation because S-oxidation is more common than S-dealkylation, and N-dealkylation is more common than N-oxidation. So if I just said that too quickly, just look at what's highlighted as the more common routes with regards to nitrogen and sulfur. Okay, and Again, keep in mind that there are other enzymes besides CYP450 enzymes that could do alcohol and aldehyde dehydrogenation. But all 6 of these that are written here, all of these different phase 1 metabolism reactions, those are classified under CYP450 enzymes. So I want to be really clear about that. So here's CYP450 enzymes. All 6 of these reactions are classified under CYP450, right? Which is also, don't forget, under oxidation, which is all under phase 1 reactions. So make sure you're good with these classifications. What I like to do on the beginning of an exam for metabolism, I write out all these metabolism reactions on the side so I know what to check for, like aliphatic hydroxylation, aromatic hydroxylation, etc. Now, phase 2 is my favorite because these are all conjugation reactions. So these include glucuronidation, right? So glucuronidation happens on a lot of different groups. What I mean by that is it can happen on like a carboxyl group, COOH, or NH2, or OH, but we're going to talk about this in more detail in a later video. Right now we're just classifying phase 1, phase 2. Then we have sulfation, and then we have glycine conjugation. And this one is really similar to the formation of a peptide bond. So we know that glycine is an amino acid. So when we do this one, you might have flashbacks to when you learned about peptide bonds in undergrad. It'll look really similar to that because it does form a peptide bond. And then we have glutathione conjugation, which is really important for detoxifying the toxic metabolite of APAP, Tylenol. So that's glutathione conjugation. And then we have acetylation and methylation. Right? And then I'll emphasize the ones that are emphasized in your lecture and in several practice problems, so you'll see which ones are more common than others. So make sure if I tell you any of these names, like aliphatic hydroxylation or S-oxidation or glutathione conjugation, you know if it's phase 1 or phase 2, and you should know that all of these CYP450 enzyme-mediated reactions here are under oxidation within phase 1.